All right. So here we go. What do we have to do first so we can use our calculator? Yeah, get y by itself, right? So I like to leave y on the left. So I'm going to subtract the x squared and the 3x over. All right? And then I want to subtract the 2x over for the linear one. We okay with those? Any questions so far? All right, I'll do the same thing over here also. But here, since it's a negative y, I'm going to add it over so it becomes positive. And I'm going to take the 5 over by subtracting. All right, so I still like to put y on the left, but the x squared would stay positive, and the 2x would stay positive, and then the 5 becomes negative. So make sure your 5's negative. And then here we're just subtracting the 2x like we did over there. But we got a plus 7 this time. Okay? And then we just put them in our calculator. We having any issues calculator-wise? You guys are pretty good at it now? All right, so let's just do this real quick. So we got x squared minus 3x. And then negative 2x. Remember, the negative is down here at the bottom. Negative 2x plus 5. Don't hit the minus sign there. And then hit graph. It should. So that has 2 points of intersection, right? What do I hit to get to the intersection? Second trace, right? Which gives us the calc menu. All right, so second trace, calculate menu, which number 5 is intersection. All right, so when you do the intersections, you want to get close to which one you're looking for. So I'm just going to go right a little bit. So I'm closer to this one first. And then the second one's close already. So hit guess. That's not a very nice one, is it? 2.8 and negative 0.6. Is that what you guys got? Okay. I'll just write it down here. 2.8 and negative 0.6. And then the other one, to get the second one, you have to go second calculate, or second trace to get to calculate, and then 5. And then move your cursor closer to the other one. You wouldn't have been able to find that answer on your table, either one of them in your table, would you? Because your table's in whole numbers, right? So that one's negative 1. I'm just rounding to tenths. Negative 1.8. And 8.6. We okay with that? What did you guys get for number 2? Did it come out nicer, or did we get decimals again? Did you guys get that far to number 2? All right, we can check it quick. Here we got x squared plus 2x minus 5, right? And this one is a plus 7. So when I have 1 point, well, there is 2 points of intersection, isn't there? Yeah. We just can't see the second one, but we can get close to it. All right. So hitting second trace again, number 5. for intersection. I'll get that one closer that we can see first. Hit this, once you get close, hit guess, or enter 3 times. 2, 3. And then the other one, we can't see it, which is okay. I'll show you something. All right, let's go move it around. And as I'm moving, you guys see the X's and Y's changing down here? It tells you where it's at, even though we can't see it. I'm just going to stop there because I know I'm closer to that one than I am this one now. And just hit enter. Let's see where it's at here. It's really close to the same spot on the second curve. So I'm just going to hit enter and then my guess. Negative 619. I thought I heard someone say that. So there's your 2 amp. That one came out nicer. He had whole numbers. We could have found those on the table. The first one we wouldn't have been able to find on the table because, again, our table's set up right now as whole numbers instead of the decimals. We can set our table up to go by tenths or whatever we want, but usually we just keep it whole numbers. Questions? You guys feel comfortable with these? Confident? Good. Just going over, I'm figuring you got all your homework right, but I'll give you the answers just to make sure. We did what, 5, 6, 7 to start? For 5, I got, the book says 0, 2, and negative 2, 0. Had 2 answers. Number 6 had 1 answer, 3, 5. And then 7 had no real answers, no real solution because they didn't intersect, right? What was the next one we did? 14? 13? Okay. 13 was 3, 8, and negative 1, 4. And then what? 17? Is that the last one? Oh, 16? 1 and negative 7, just 1 answer? Did we do 17? Yeah. Okay, we did 17. I thought we did. That one had no solution also. They did not intersect. 16 was 1, negative 7. Any of those you'd like to go over? Again, if we miss it, it's probably we just punched something in our, in our calculator wrong. We didn't get y by itself correct, maybe. Okay? So make sure you get y by itself if you have to first, like these 2 warm-ups. All right, good job so far. Oh, there they were. I guess I could have went there, but today we had a line and a parabola yesterday, or 2 parabolas, right? Well, today you're going to look at a circle as well. Okay? So the basic or standard form of the equation of a circle is this: x squared plus y squared equals r squared. All right? The parabolas we basically been working with the x's squared, right? But there are parabolas that you just have the y squared. They are ones that open up right and left instead of up and down like the x squared. But when you have both of them squared, you get a circle. Okay? If there's no numbers with the x and the y, that means your center is at 0, 0. Okay? And then your radius is r. And you guys know in a circle, from the center of the circle to the edge is the same all the way around, right? But just like yesterday, with the parabolas and the lines, or the 2 parabolas, you could have no real solution because the line and the circle do not intersect at all. You could have 1 real solution where the line intersects in 1 spot. What kind of line is that when it only hits a circle in 1 spot? What's that name? You guys remember from last year? Remember tangent line? That's what that line is, tangent to that circle because it hits the circle in 1 spot. And then sometimes your circle or your line will go through the circle and you'll have 2 solutions. Okay, so those 3 situations could happen just like yesterday. All right. Now, we're not going to do that using graphing, our graphing calculator. We're going to do this by substitution today. All right. When we have a circle, one, and linear or quadratic one. Okay. So here we have a linear one, a line, and then we have our circle there. Okay. So when we do substitution, the first step was to get one of the variables isolated by itself. Okay. But that's already been done, right? Isn't y already by itself? So what did we do once we had a variable by itself? What was that substitution we did? You guys remember from when we did this? This earlier in the year. We did a system of equations. They were two linear equations, and we did it by substitution, did elimination and graphing. But what did we do when we did substitution? We substituted somewhere, right? Where do you think we're going to substitute? With what? Yeah, this negative 3x plus 10, we're going to put in the other equation for the y, because that's what y equals. Okay? So we're going to rewrite this top equation as x squared plus, instead of y squared, we're going to put negative 3x plus 10 squared. And then equals 10. So that's the substitution part. Now we're going to solve this equation for x. Once we get what x equals, are we finished? No, we need to find out what y equals, right? We need an x value and a y value, because our system has x's and y's in it, right? So the next step is to square this binomial. When I square a binomial, or I square anything, what's that mean? Multiply something by itself, right? So this is what we're doing. Okay, and how do I multiply two binomials? When I do that, write something like this. What do we call it? I heard someone whisper it, I thought. Yes, very good, Nick. We're going to FOIL it, right? First outside, inside, last. So first is negative 3x times negative 3x, which is positive 9x squared. Outside is negative 3x times 10. Inside is 10 times negative 3x. And last is 10 times 10. You guys remember how to do that, right? Yeah. Now, I also gave you a little shortcut way for those, if you remember. The shortcut way is take the first term, the negative 3x, and square it, which is all we already did, which is what? 9x squared. The second part is multiply the two terms together. What's negative 3x times 10? Negative 30x. And then I told you to double that. What's a double of a negative 30x? Negative 60. As you can see, we have two negative 30s here when we FOILed it, right? So if you don't want to do the FOILing part, you want to remember the shortcut, you can. And then the last term is always the second term, the 10 squared. What's 10 squared? 100. So there's what we have. All right. So now that I've done that, here's what my equation looks like. I've got this x squared still. And then it's plus 9x squared minus 60x plus 100 equals 10. Well, what's x squared plus 9x squared? 10x squared, right? They're like terms. So let's simplify this. And since it's x squared, it's a quadratic equation. What have we always done when we want to solve a quadratic equation? Set it equal to 0. Yeah. So what I want to do with this 10 is I want to bring it over here as I'm doing this. So what's 100 minus 10? 9. So now I have it equal to 0. Now we've learned a bunch of different ways to solve the quadratic equation. We've learned factoring. We've learned completing the square. We've learned graphing. We've learned the quadratic formula. At this point, you can do it however you want. Okay? I like to try to factor first. That's because I do that a lot. All right? Do you see a GCF? Yeah, 10, right? So I'm going to take a 10 out of each one. And then I get x squared minus 6x plus 9. All right? Are there factors of 9, two numbers I multiply to give me 9, that I add to get negative 6? Negative 3, right? Because it's a negative 6. So, since this a is 1, that's like this. It's actually one of those special trinomials. So I could have wrote x minus 3 squared, right? You guys remember that? So once we were here, we set the factors equal to 0. This was the next step. Can I say 10 equals 0? Can I set 10 equal to 0? Is that a true statement? No, so I wouldn't worry about that one. If it was 10x, yeah, there was a variable with it. So that means, or x minus 3 equals 0. Do I have to write it twice since there's two of them? No. So what's my answer for x? 3. Again, are we finished? No. Remember, this is a system. There's an x value we got to figure out and a y value. Okay, any questions on how we got to the 3? Again, if you want to use quadratic formula, if you do not like factoring, you can always use the quadratic formula. Okay? And remember, that's this. X equals negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. It was on our last quiz, right? You can do that. You don't have to factor. I just like to try to factor first. It's usually a little quicker. All right? Now, like I said, we're still not finished. I got to take this 3 and plug it into one of the two equations that we started with to find my y. Which of the two would have been easier? The y equals 1, right? So I want to put that 3 right here. Right here for that x. All right? So y equals, why does that keep doing that? Berkey, are you making it do that? You sure? Maybe it's Vince.
No, that's okay.
So remember, it's negative 3 times x. So x is 3, and that was plus 10, wasn't it? So what's negative 3 times 3? And what's negative 9 plus 10? All right, so our answer is this ordered pair. If I put 3 in for x and 1 in for y in both equations, I'll get a true statement. Let's just check real quick. What's 3 squared? What's 1 squared? What's 9 plus 1? 10. And then negative 3 times 3, we already said was negative 9 plus 10 was 1, right? Or I basically checked it there. Okay? So, when we have a circle, remember, when you have the x and the y squared, and we're going to solve a system, we're going to use substitution. Okay? Any questions of any part of that? All right? So we wanted to get a variable by itself. Usually it's the y. That's what we're used to doing. And then we plug that in, whatever y equals, into the circle equation, and then square it, combine like terms, and solve for x. We're going to get a quadratic. All right, so we got the same deal here, right? Why don't you guys work on this and see how you do? All right? It's hard to graph the circles on your calculator. But if we did graph the circle and the line, we could find those 2 points. Okay, what's that? Good. So what's that? You got that x squared. That's good. Right. You just factor out. Right. 2 on the front, so you remember it. Good. Good. Now the factor is 6 there. Okay, I'll give you a hint. This won't factor, so use quadratic formula to solve it. Quadratic. Yeah, that won't factor now. Yeah. X squared. Where'd this one come from? Yeah, pull that out. But then after that, it won't factor, so then do the quadratic formula. You guys are doing well. It won't factor.
How did I?
So use the quadratic formula instead for this one.
Go with everything.
Yeah.
No. I've been sloppy. I've been sloppy. Why can't you have a negative? Is that what you got? Yeah. 2x.
All right, you guys are doing well. let's go ahead and, if you didn't quite get finished, that's okay. Where am I putting x plus 4?
Up there.
In for the y, right? Just like we did before? So we got x squared plus x plus 4 squared equals 4. When I walked around, everybody had that part right. Okay? And then when we do the shortcut squaring a binomial, you take the first term, x, and square it. So that's another x squared. You multiply those two together. What's x times 4? 4x times 2, double it, 8x. And then square the second term. What's 4 squared? 16. So to set it equal to 0, and combining like terms, we're going to subtract the 4 and get a 12. All of you get there? Okay. Now, everybody sees that, 2 goes into all of those. So I saw a lot of people factor out the 2, which is good. But when we got here, then, we look at the 6, you got 1 times 6 or 2 times 3. Either one of those, when I add them, is not a 4, right? So it's not factorable trinomial. So I would use the quadratic formula to do that part. So, it's x equals negative b, and b is what? 4. And you could do it from up there, too. You could use the 8 and the 2 and the 12, or the 1, the 4, and the 6. I just used the 4, and 1, 4, and 6. So negative b plus or minus the square root of b squared minus 4 times a times c over 2 times a. Okay? So that gives me negative 4 plus or minus something over 2. Well, 4 squared is 16. And negative 4 times 1 is negative 4 times 6 is negative 24. 16 minus 24 is a negative 8. Since we have a negative in there, what's that tell you? Imaginary, right? Will we see, if we were to graph them meet then, if it's an imaginary answer? No. There's no real solutions to this. So if you use the quadratic formula and get a negative, like we did here under the radical sign, that means there's no real solutions. We're getting into the imaginary solutions. All right? So we're just looking for real solutions on these systems. So if I were to graph the line and the circle, they would not meet. Okay? Does that make sense? Do we understand this substitution method? Do we need to do another one? No, I think we're fine, aren't we? All right. Again, we would take x plus 2 and put it where? In for the y squared, right? And then go from there like we were doing. All right, you guys did an awesome job again today. There's your assignment. Those two that are underlined, 14 and 15, are the ones with the circles. So use substitution for those, okay?
Not only did you fail at doing I think it's 3 instead of 5. Yeah, if you look. Oh, no. Yeah, if you look at the date and stuff. I think if you go to Canvas Gradebook and then you click on the assignment, that day it should show you the page. Did you do that practice yet? Did you try to do that practice? When you get that done, let me know so I can go over it with you. If you ready for the quiz.
It's just like a balloon and had like ball in it.
Why does it got a balloon
To make him feel better?
Yeah, so, that's one of your priorities. This stuff you're understanding, right?
And Connor's gonna stay after school with me tomorrow for a little bit.
Before you guys go practice.
We don't have practice on Thursday.
Cool. Yeah. It's good. I think you guys work pretty well together when you work at it and not start picking on this. Is my.
This is my.
Well, you gotta get those other ones done.
I want to get this one. Bam, 2 online classes.
Oh,
So
come
it's 3.
on.
So I only need 2. Like,
Yeah.
get yours up and then do biology. Pass.
Yeah.
Keep over. So
Yeah.
I want to do this one first. So.
Yeah, okay. Yeah, that's fine. I'll let you do that.